Good morning, Chem 1. We are slowly moving toward the end of the school year. We just got a few more days of content left and we'll be all done. So we're going to continue forward today with solutions, and today you could think of as math day. We have a bunch of different ways to calculate the concentration of solution. Concentration is probably something you understand. When something is concentrated, like if I said concentrated lemonade, you would think, okay, that's really strong. Or if I said dilute lemonade, you would understand that to be kind of watered down, right? Not quite as much solute. So dilute would be lots of solvent. Concentrate would be lots of solute, relatively. So let's go ahead and get started here. We're going to do a lot of math. I'll point out some things, but the math is pretty simple. I'll just kind of point some things out here as we kind of work through these. So I already kind of discussed this with concentrated and dilute. Concentrated would have high amounts of solute. Dilute would have low amounts of solute in terms of the solute to solvent ratio. But we would, in chemistry, sometimes we need to mathematically calculate this concentration. There's a couple different ways to do that. The first one is called molarity. It is the most common. When I make solutions of acids and other chemicals in lab, I use a molar solution. And I take the moles of the solute and I put them over the volume of the solution in liters. Has to be in liters. And that measurement is known as molarity. It's very basic. It's only three variables. And your job will just be to, I'll give you two variables and you find the third. So for instance, if I said you have 45 grams of NaOH are dissolved in enough water to make 1500 milliliters of solution, what's the molarity? The first thing that you have to notice is that we don't have moles or liters. Liters is pretty easy. We're just going to move the decimal 3 to the left, and that makes this 1.500 liters. I guess the zeros don't need to be there because they're not significant. And then we would need to take 47.5 grams and convert it to moles. So the first step would be to take 47.5 and divide by 40. This is the molar mass. Because when you divide by a number of grams by the molar mass, so molar mass would be 1 atom of sodium, 1 atom of oxygen, 1 atom of hydrogen, and then that would give us the moles. And then we divide by 1.5 liters, and that would give us 0.79, and we just put a capital M for molarity, okay, or molar solution. So this is actually one of the more complicated problems because you have to do two conversions before you can get moles and liters. But this is pretty much as complicated as it's going to get for molarity. 1.78 grams in a 200 milliliter solution, same idea. We're going to divide by the molar mass of calcium bromide, and that gives us the number of moles. And then we're going to divide by the number of liters. So we changed milliliters to 0.2 liters, and we get a 0.0445 molar solution. So molarity, really, that's it. There's not too much else to it. Okay, there's a couple other things here. This is if you're preparing a solution. This is a version of the equation is used when there is a particular molarity that is desired, and you need to know how much solute to make. So if I said make a 5 molar solution, so you know your molarity, how much solute do you need? You would calculate it like this. This is still M equals moles over liters. We've just rearranged the variables algebraically to put moles of solute and set it equal to moles of solute. All right, so how would that look? How many grams of calcium bromide are needed to prepare 2.5 liters of a 1 molar solution? So we just take molarity times the volume, and it would tell us we need 2.5 moles, and then we multiply by the molar mass if we want to know how many grams. This is the kind of thing that chemistry teachers and chemists do all the time because they need to figure out, like if I want to make a solution that's a 1 molar solution of calcium bromide, I need to know how much chemical to put in the water, and I need to know how much water I have. Here's just another example, a couple more conversions that may need to take place, but it's the same idea. All right, so that's molarity. By the way, all these equations we're going to talk about today are on your equation sheet. But yeah, it's really just plugging numbers in, finding an answer. All right, I'm going to skip past this so we can get to diluting a solution. We'll get to molality here in a second. This version of the equation is used when a solution of high molarity is diluted with extra solvent. So the idea here is when we get acids from a scientific supply company, it's concentrated, and it's like 16 molar, which is really strong, really dangerous, and we wouldn't use that in lab. So we would dilute it to a lower concentration, like 1 molar or 3 molar, so that it's safer to use. And the way we do that is with this diluting equation, M1V1 equals M2V2. And the way you do that is you put the molarity of the first solution and the volume of the first solution, and then either the molarity or the volume of the second solution. So let's take a look at this here. You have 6 molars of hydrochloric acid, and you need to make 1.5 liters of 1 molar solution. So you can see here that we already have 2 molarities to deal with. It doesn't matter which one's M1 and which one's V2. So if we call this one molarity number 1, then I know that this is molarity number 2. But notice how these liters are tied to this molarity, which means this has to be V2. If you made that 1.5 liters V1 and paired it with the 1 molar, it's not going to work out correct. And at this point, you're just setting it up. It should look just like this. 6 times our V2, our V1, we don't know what V1 is, equals 1.5 times 1. And what that's going to tell me is how much liquid, or how much of the 6 molar solution I need in order to dilute it to this concentration. So M1V1 equals M2V2. And the easiest way to identify these is by identifying the fact that you have more than one volume or more than one molarity. Notice how these two are tied together. It's 25 mils of 12 molar. So here's the thing, you don't need to convert these milliliters to liters. And the reason is because you have milliliters on both sides, that unit's going to cancel out anyway. So we can go ahead and leave it like this. Simple equation. Solving for M2 is what we're solving for here. 0.6 molarity. That's how much, that's the molarity of the 500 mils you'll need, okay? Or what you'll make. So molarity is our M1V1, M2V2 is for diluting one concentrated substance to a dilute or less concentrated substance. So molality is the unit of concentration used for high or low temperatures. So here's the problem. Molarity takes into account volume. Well, when heat goes up and down, the volume of a liquid is going to expand and contract. And so that's going to change the molarity theoretically. So anytime that you're using extreme temperatures, high or low, you really shouldn't use molarity. You should really use molality, because molality still have moles of solute on top, but now on the bottom, the solvent is based on mass, not based on volume. Guess what doesn't change with temperature? Mass. If you have 1 kilogram of water, you'll have 1 kilogram of water no matter what the temperature. Now, even if it expands, it's just becoming less dense. Okay? So it's a very similar equation. The thing that's a pain, kind of, is it says it's molality. It's literally 1 letter difference. And so you got to be real careful not to come, like reading the question, making sure I'm asking for molality and not molarity and vice versa. But it shouldn't be, the math's the same. Pretty simple stuff. What is the molality of 35.6 grams of NaOH is dissolved in 200 grams of water? So the first thing we need to do is convert the grams of water to kilograms, which once again would be 0.22 kilograms. That's going to go on the bottom. And then we need to take the 35.6 grams of NaOH and convert it to moles. So we're going to divide by the molar mass of NaOH. That's going to give us this many moles. And then we're going to put this many grams, or kilograms of solvent on the bottom. We divide out and notice that we have lowercase m, molality, 4.45 is what we got there. All right. So just remember to keep your units in this correct, like you need moles, kilograms, liters, whatever it is you're looking for. Here's another one. I'm not going to spend a ton of time on this because the math is pretty basic. We got to get from grams to moles first. And we got to get this grams to kilograms. And then we divide them out, moles over kilograms, to get our molality. This is mole fraction. I will go over this real quick. Just know that this is not going to show up on a quiz or anything. All a mole fraction is it's used when you have more than one solute. So like for instance, lemonade has sugar, yellow pigment, some lemon. There's lots of things dissolved. Now we wouldn't probably use a mole fraction with lemonade, but the idea is you have more than one thing. And the way you do it is you take the moles of the thing you're focusing on, the specific solute, and then you add up the moles of all the other parts. Okay, this is kind of a lesser known concentration equation. So here's one way to think about it. What is the mole fraction of N2? And they're talking here, it looks like about air. So you would look at N2, which is 2 moles, and then you would add all the other moles together, and that would give you the ratio of N2 to the total solution. We're not going to spend a ton of time on the mole fraction. I just actually spent all the time I'm going to spend on it. I want you to focus on molarity, M1V1, M2V2, and molality. Those are the 3 that will show up on your quiz. And I'm not going to try to trick you and make a complicated problem. Like, they're going to be pretty straightforward. As long as you understand your variables and know where to put things, you'll be fine. I would recommend the practice on this section. Work through some of the problems so you're at least comfortable with them. I don't spend time on mole fraction. You don't need to do that. But we will have a quiz here in a couple days, and we'll see how we're doing. Okay, and that'll be it. We'll be done. So good job today. Be good to somebody today. We will see you soon. We got one more section, and then we'll be done. Have a good one.